So welcome everyone to today's session of exploring the elements and interconnectedness of our local food system. I'm Maria Pepitas with the University of Delaware Cooperative Extension, and my co-host today is Jerry Hush, also with the University of Delaware Extension. And we are really pleased to be continuing on with our series helping people really understand, better understand the characteristics of our local food system, of being able to understand some of the opportunities that might that are out there that may help us strengthen our food system, and to better understand how you might become more involved in strengthening our food system. And this is an image that we've been using throughout our webinar series to kind of help show the complexity of our local food system. And you can see, it includes the land, and it includes the farming parts, and it includes the consumers, and sort of all the other kind of the circles that impact our food system. And today we are going to focus on the sea. And I'm so excited to learn more about our seafood industry and aquaculture. And I'm really excited to also share that this is a very well-supported initiative through our Department of Agriculture and through the Center for the Inland Bays and our Department of Natural Resources, and through Del State Extension, as well as the University of Delaware Extension. University of Maryland is also very supportive, as well as our University of Delaware Sea Grant program. And so I am really pleased to introduce our speakers today. And they include these folks up on the screen: Chris Petrone, who's the Extension Director of Marine Education with the University of Delaware Sea Grant Program; Dennis McIntosh, who is with Delaware State University in the Department of Agriculture and Natural Resources, and he is a professor and extension specialist in aquaculture. We also have Ed Hale, who is also with the School of Marine Sciences and Policy. He's an assistant professor and Marine Advisory Service specialist with University of Delaware. And we have someone kind of from the corporate world, Greg Caston, and he is with an organization called ProFish. And so without further ado, I am going to stop sharing and turn it over to our speakers.
Great. Thank you, Maria, for that introduction. Appreciate it. So good afternoon, everyone. My name is Chris Petrone. As Maria said, I'm the director of the Delaware Sea Grant Marine Advisory Service. I am based at the UD campus in Lewis, down in Sussex County in the beach there. And it's my honor to introduce or moderate a panel today with Dennis McIntosh, Ed Hale, and Greg Caston. I think first we're going to kick it off with a bit of an introduction to sort of fish supplies, fisheries, and aquaculture from Dennis and Ed. So Dennis, whenever you're ready.
So really, I always like to have a conversation about seafood, and when I'm asked to talk about aquaculture, which is my area of expertise, I really like to make it a larger umbrella than that, because it's important to keep in mind that when we're talking about seafood, it is really more than just aquaculture, but it's fisheries as well. And so today we're going to try to talk in kind of broad strokes about this industry a little bit, and try to bring that down to what's happening locally in Delaware to kind of give you some perspective. So, as we talk about seafood, and, Maria's diagram at the beginning showed the idea of production and demand and balancing those out. And I think this is a great segue to that conversation. As we're talking about seafood in the United States, we generally run a fairly large trade deficit in terms of the seafood that we consume here in the United States. You know, a lot of numbers here on the screen, but the key one here is that we're about $17 billion. So we're importing a large amount of seafood every year into our country from all around the world. You know, Southeast Asia is a big exporter. We import a lot of things from there, but realistically, we are importing seafood from all around the globe. And so, you know, we have a great business in seafood. There's products coming in from all over, and it's not necessarily stuff that's locally produced, although it may be interesting to some that there is a fair amount of product being produced locally, and you may not even be aware of what those products are. You know, part of what's driving that and part of where seafood in the United States differs, I think, a little bit from other parts of the country or other parts of the world, is that on a per capita basis, our seafood consumption is roughly half of what it is around the world. You know, and this is kind of an interesting thing as we start looking about production consumption patterns globally. You know, we tend to eat seafood, but as a country, we tend to eat seafood that tends to be higher on the food chain. And so oftentimes those products are more resource intensive to produce. There are some great exceptions to that rule, but by and large, we're eating things like salmon and other things that are on the higher end of the food chain. So per capita consumption in the United States has increased over the years, as you might expect. It's always fun to show this slide when I'm dealing with my undergraduate students. It used to be that some of them were born in the 80s or even the 90s, but in reality, most of them now are, well into the 2000s when they were born. So it's the joke is no longer funny for me. But what we see here is really around 1984, we see kind of a peak in seafood production. And it's really about that time when the science was coming out that eating a diet that was rich in red meat, kind of that meat and potatoes diet really wasn't heart healthy. And so people started to increase their awareness of seafood as an alternative, but also the health effects that seafood can bring with it. And then coincidentally, or maybe not coincidentally, haven't really looked into it that far, about the same time, we really see the commercialization of some technologies that allowed seafood production in an aquaculture setting to really take off on the commercial scale. Things like shrimp aquaculture really come into technological significance at this time. And so, not only do we have an increased demand because of changing perceptions of food, but we also have an opportunity where we're seeing an increase in supply and availability. So no longer is shrimp just something that happens in the fall when it's harvested wild, but we can actually grow shrimp and produce it and supply it all year long. So again, our dietary habits are changing over time. This is always a fun slide to show too. This is the top 10 seafood species that are consumed in the United States. Most of these things are probably quite familiar, with the possible exception of Pangasius. Pangasius is a catfish analog, if you will. And so it's a flaky white fillet type of a fish that's largely imported from Southeast Asia. But these other species are things that are probably quite common, quite familiar to you. And interestingly, the little species with the asterisk next to them, shrimp as an example, are things that are grown in large part in aquaculture settings, or there's a significant amount of aquaculture production. As in the case of salmon and shrimp, both actually, there's a wild harvest for those products, and they're great products that are coming from the wild, but those products are also farmed in a great way. So the supply that you're seeing locally is probably coming from a farm supply, possibly from a wild supply too, depending on where you're buying your seafood. There are other species like tilapia, where there is very limited actual natural harvest of that product, at least that's being exported, certainly in countries where tilapia occur naturally. Think Africa and the Middle East, where that species occurs naturally, there is some wild harvest, but for the most part, that's a farmed product. So as you can see, lots of things here that are aquaculture species, really with the exception of pollock, and pollock is a species that is exclusively at this point wild harvested. And so that's where that supply is coming from. But that's a really well managed fishery and why it's been sustainably harvested for so long. So it really kind of brings up this question of where do fish really come from? And at the end of the day, it is a combination of aquaculture supply and marine and aquaculture and marine and freshwater fisheries. So it's really those two legs to the stool that are kind of providing our supply of seafood in the United States. And from there, I'll turn it over to Ed for a few minutes.
Sure. Thank you, Dennis. So I suppose first we should probably define what a fishery is. As Dennis mentioned, there's potentially 4 different vectors or pathways that we can acquire seafood traditionally if you're not growing it yourself. And the 2 that I'm going to focus on are fisheries. We don't have any freshwater commercial fisheries in the state of Delaware, but we certainly have plenty of recreational fisheries. So perhaps we can toss up some bullets to actually define what a fishery is. So a fishery is any activity leading to the harvest of fish. And that can technically include wild fish harvest, which is what we typically denote, or some level of aquaculture-based intervention. But for our purposes, we're just going to leave it to wild harvest. And then if you click the second bullet, that how you actually define that can be defined fairly, through different ways, right? We can an area of water, method of fishing, a class of boats, like size. So we might have like the Northwestern cod fishery, industrial scale, large vessels, and then you can define it based on, so we can say port or something like that. And so you can really discuss what a fishery is based on who's involved, the size of the boat, and where the activity is occurring. Typically, in terms of a management context, we use species or groups of species. You may have heard of groundfish. And so that's, some 20 different species of fish that are prosecuted using largely bent thick trawling gear. And so that's very much its own fishery. Next slide. So why should you care about fisheries? And Dennis, you can feel free to just kind of click away. The first bullet really is kind of the ecological context. So fisheries contribute to healthy ecosystems, not just through top-down control through predation, but also through contributing nutrients, right? We think about things like nitrogen and phosphorus in fish waste. Well, those elements actually contribute to algal and seagrass growth. And so fish are very much a part of the ecosystem in which they're entrained. And so when we extract them for commercial harvest, there is essentially ecosystem level responses. And so we need to be cognizant of that, and that there is an impact to our ecosystems. The second bullet I'll talk about are global dietary needs. So about 20% of the world's population derives at least 1/5 of its animal protein intake from fish. And many small island states, particularly in the Pacific, actually depend much more on fish in terms of its protein composition for nutritional dependency. And so we can see just between ecosystems and dietary needs alone, how significant this value can be. And then I like to bring up economic value last, because if you haven't really attached yourself to healthy ecosystems or global dietary needs, it's perhaps interesting to note that U.S. commercial and recreational saltwater fishing industry is about $212 billion in sales and contributes $100 billion to the gross domestic product. So Dennis mentioned a $16.9 million trade deficit. Here's an industry that's worth $100 billion to our country. And so it really is rather significant. You can look at it in terms of full and part-time jobs, 1.7 million full and part-time jobs. Very, very significant industry, particularly along coastal regions like the Mid-Atlantic. So there's the trade deficit. NOAA tends to report. These figures are from 2017 and 2018. There's a little bit of disagreement between how these numbers are supported. But overall, what we see is that the trade in terms of seafood import versus export is typically ranging in deficit mode. We are almost always in the red. You can see from 2017, it was estimated 7.7 billion, 2018, about 16.8 billion. I'm not sure that there was a really significant difference in consumption patterns between those 2 years. Rather, I suspect that there was some level of estimation difference that occurred at NOAA Fisheries. But still, this is helpful to get a kind of an idea of what's going on. And if you look to the figure on, I hope it's on your right, the 2018, you can see some of the things that Dennis had mentioned, including shrimp, with imports being, $6 billion worth of imported shrimp from other countries, which is fairly substantial. And then you can look at what we're putting out. Most of that is actually whole fin fish. There is other edible products. This is some products that are sent out for value added, essentially ingredient augmentation. But just to give you an idea of where our national performance lies in terms of trade value, that's about where we are for 2017 and 2018. So when we look at some of our recreational fisheries, which are actually consumed depending on the recreational angler, but many of them are actually harvested for consumption. No surprise that many of the species you read about, bluefish, black sea bass, striped bass, Atlantic croaker, are typically being harvested in high numbers. And you can actually see the red and the green in terms of who's being harvested and likely consumed and who's being caught and potentially released. And so we do see these types of trends. When you look at saltwater trips and catch, we see that the recreational fishing industry, 194 million fishing trips is really fairly substantial, and 8.5 million people engaging in this activity, which is, again, another significant economic engine for our country. All right, now when you get back to our commercial landings and values, we see that 2017, we landed about 9.4 billion pounds of seafood worth approximately $5.6 billion. And a lot of the highest values are the things that you would attribute this to, right? When you go and look at the grocery store: lobsters, sea scallop, salmon, wild caught shrimp, things that you pay a premium for when you go to the seafood counter, and it's a US sourced product. And so we can kind of see that. We can also compare relative port or area values. We look at the Atlantic, we have 14% of the landings, but about 37% of the value. So we have essentially this agreement between the total amount we're landing and the total amount of value. Whereas when you look at Alaska, 58% of the fish are landed in Alaska with 32% of the value. And so that kind of makes more intrinsic sense in terms of higher production, higher value. But that tends to coincide in the Atlantic with a higher per unit value per product, right? And so we're landing sea scallops in particular and lobster in the Atlantic region. And so if you look up at that gray bar, that's why, because those products are difficult to acquire. Both of them have relatively short seasons, and so it kind of drives up the price value, as well as consumer interest. So how are your fisheries managed? We can talk about this in a number of different ways. Essentially, your federal fisheries, those that extend from 3 nautical miles to 200 nautical miles, are managed through something called the Mid-Atlantic Fishery Management Council. This is a federal set-aside that runs through NOAA, which is one of the regional councils or bodies that governs fisheries management and regulations. Each state is going to have a representative that participates in this from both the state wildlife or Fisheries and Wildlife Agency, as well as individuals that are appointed from the government. Within inshore waters, tidal inshore waters to 3 nautical miles, we regulate fisheries through the Atlantic States Marine Fisheries Commission. This is a little bit different in that it's not a true federal body. Rather, it's a compact of all the coastal states from Maine to Florida that have an agreed shared upon resource utilization plan. Similarly, there's representatives that participate at the state level that go and help assess. And what both of those groups do is essentially engage in stock assessment, where we're trying to estimate population dynamics like mortality and abundance so that we can regulate our fisheries for consumptive purposes. Some of the things that we do to manage our fisheries include things like regulatory controls. We think about effort, reducing effort, and talk about increase or decreases to quota, establishing protected areas. We can also look at conservation and protection, and primarily source those through anthropogenic issues, right? We're trying to manage or mitigate human-based threats. And then we can look at habitat manipulation or rehabilitation, including things like dam removals and that type of thing. And then finally, we can look at actual fish stock enhancement. Now, this might sound foreign to you, but understand this: in the state of Delaware alone, there's actually an American shad hatchery on the Nanticoke River, the Delaware portion of it. And so we are artificially inflating the wild biomass of American shad by catching wild broodstock and essentially growing larval fish to fry and then releasing them. So that's a form of enhancement. It is very much an artificial introduction of fish where we are essentially attempting to affect survival and potential juvenile recruitment. Okay, so as I said, within Delaware, we have fisheries that are managed at the council level, the Mid-Atlantic Fisheries Management Council. These are from 300 to 200 nautical miles. Then we have the Atlantic States Marine Fisheries Commission, which manages from inshore tidal waters to that 3 nautical mile limit. And there are some species that essentially are managed by both, like black sea bass, but just for the purposes of this conversation. And then we have fisheries resources that are just wholly managed by the state. And so we can use blue crab as an example of that. We essentially engage in our own state-specific stock assessment of blue crab abundance based on several of our survey indices and incorporated population dynamics parameters like mortality. And then we feed that into a model and predict abundance so that we can adjust things like commercial quotas as well as recreational take limits. So that's how we're managing fisheries. When you consider this on a national basis, so we have overfished some species. We know that we've done this, particularly those that occur within the estuary that have essentially a vulnerable life history stage that allows them to be harvested beyond what is reasonable in terms of sustainability. But when you look at it from a national perspective and kind of step back, turns out that when we look at overfishing, who are we presently overfishing? Overfishing is an immediate sense. And so there's 2 terms when we conduct a stock assessment. We assess whether or not overfishing is occurring, and we're assessing whether or not the species has been overfished in the past. And so overfished is very much a past performance metric. Overfishing is an immediate current temporal terminology. So when we look at overfishing, we essentially have a 91%. So we have an A in sustainability. And when you compare that to global trends, the United States really is a leader in sustainable fisheries access and resource management. It's really fantastic. When you look at our history in terms of who's been overfishing, we bring it down, right? The grade kind of comes down, and that represents essentially years of overharvest, construction of impediments to diatramous fish passage and migration, and water quality issues. So we've seen those, really since the late 1800s till about the 1960s. And so, really the chance for improvement in population recovery is relatively modern. And so we're trying to assess that now. But again, overall, we're doing very well in terms of our national average. When you look at some of the commercial fishing gear used in Delaware, as well as the Mid-Atlantic, some of the things you probably have heard are dredges. Probably heard about dredges for crabs. This figure on the lower left is what a hydraulic dredge looks like. Excuse me, it's not hydraulic, it's just a bottom benthic dredge, and that can be used for oysters or crabs. There's also gill nets, so we can use sink gill nets that are anchored to the bottom, like the ones you see in the picture, or drifting gill nets that actually float passively. And what happens is the fish swims along and gets trapped in the operculum. These nets are actually very active in acquiring fish species. The commercial fishers that use them are very efficient. And so what happens is we manage fisheries that are engaged with them, like striped bass through quota. And so it's incumbent on the commercial business owner to essentially go out and capture the fish. Some of the other things we use are traps. We use traps for blue crabs. We also use them for American eel, whelk. There's a number of different species. Black sea bass are caught using traps, pots. Those are different terminologies there. So you might hear gill net or net, dredge, and pot-based fisheries, and all of these things essentially contribute to all of the species that we harvest commercially. This is just a quick picture of what a gill net looks like. So many of you probably haven't seen a gill net in the water. This is a good example of a Delaware Bay-based fishery. We have relatively small, they're not quite artisanal, but they're fairly small scale commercial fisheries activities. You can see the net actually hanging off the bow of the boat, and it is being retrieved on that drum reel, being picked in, and then as it comes in, the individual fish will be pulled out of it. And so this is just a typical example of see on the water there. And again, when we look at our commercial fisheries values, we're talking about ex-vessel value. This is not all of the associated impacts that are associated with things like our recreational fishery. So when we look at our recreational fishery, we include things like gas, bait and tackle supplies, secondary home purchases. In the commercial fishery value, we're only talking about ex-vessel value. We're not even including the price of gasoline. So there's a little bit of difference and nuance to the way these two values are calculated. But in terms of the total, we can actually see that we're generating economic impact in the hundreds of millions of dollars range just for the state of Delaware. And so that's fairly exciting from my end. And that's kind of why we're involved to help augment that and help provide sustainable information there.
Okay, thanks, Ed. So going to switch gears a little bit and talk about aquaculture. As Ed mentioned, fisheries really does cover the wild capture as well as the commercial growing of fish species. I give Ed a hard time all the time that, aquaculture is different than fisheries and that we're somehow better, but that might just have to be one of those arguments that we take to the bar one day and have a beer over. But so this is the definition that I like to use of aquaculture. And really it's kind of simple, but it's intentionally quite broad at the same time. So aquaculture is the farming of aquatic organisms, including fish, mollusks, crustaceans, and aquatic plants. And the key here really is that we're doing something to enhance that stock that we have out in the wild, and that may be bringing that onto the farm. In the case of, say, a channel catfish, where we're putting that into a pond, it may be the case of supplementing that population, as in the example of the shad that Ed mentioned. So there's lots of different ways that we can kind of imply some or apply some farming techniques to seafood. And again, depending on the species that you're talking about and depending on the particulars of that species and where it's being produced, this can be very, very broad, from very simple enhancements to very complex land-based recirculating systems where the whole life system and the whole life cycle of the fish is controlled to get it to produce when and how we want it to. So the aquaculture industry has really been growing quite a bit, and these numbers are outdated, but they really are just shown to kind of prove a point, and not to suggest that traditional agriculture or capture fisheries are not significant and not important. But there has been a lot of growth in the aquaculture sector. As I mentioned earlier in my introductory part, part of that is an acknowledgement that eating things that are not red meat can be a heart-healthy alternative. The technology has improved year over year to allow us better to grow these species that we're interested in. So there's a lot of drivers as to why aquaculture is growing. And again, one of these is the economic numbers that Ed showed and that we talked about, that there's demand for these products. People want these products. They can't necessarily get them all the time, depending on where you are. And so growing them and having them produced gives you options on how you can access seafood. This is always an interesting slide to kind of talk about if we look at aquaculture production over time. Again, it has not been that long, a few decades where we really had no aquaculture production to, significant portion of our fish that's available worldwide is coming from aquaculture production. So the green line at the bottom represents U.S. aquaculture production, and there's a variety of reasons that we can talk about as to why that has been lagging compared to other parts of the world. But you can see that aquaculture production around the world, the blue line at the top, is really taking off. And similarly, we see a similar pattern in China. It is interesting that a lot of the aquaculture data that we report will actually have numbers including China or numbers excluding China. And China is a really, really large player in global seafood markets, but they're also a very large consumer. And so oftentimes their production, though quite large, is overshadowed or kind of almost completely overshadowed by the amount of consumption that they have in China. So in the world stage, they are a big player, but they're also a big consumer. So there's not necessarily an abundance of product coming out of China for other places. So a similar graphic to what Ed showed earlier tells us what the aquaculture industry looked like in 2018 nationally. And so in the middle there, you can see the prime species of marine aquaculture: oysters, clams, salmon, mussels, and shrimp. And these are the things that are, growing largely in the United States, depending on where you are. The species of oyster, for example, may change a little bit from the East Coast to the West Coast to the South. But oysters are still being produced, and they're really one of the largest aquacultured species in the United States currently. And certainly we're seeing a similar trend like that in Delaware. This is always a fun slide to put up too, just to kind of show people where aquaculture products are being produced. If you're paying real close attention, you'll notice that the states here are not necessarily the states that were, kind of highlighted on the last slide. Mississippi is the largest aquaculture producer in the United States. They're producing largely channel catfish in ponds. And so again, we're seeing these numbers change every couple of years. The last census of aquaculture was done in 2018. There'll be another one coming up this year. We're actually hoping that Delaware will actually make it onto the board this year, now that we have more than one or two aquaculture growers. The federal government has tried to protect individual farmers, so they haven't published actual values of aquaculture production for states that have only a few aquaculture producers. But I'm confident that this year we'll kind of pass that threshold, so we'll be on the board officially. So production technology is varied quite a bit, as with capture fisheries, and these are four of the most common ways that fish can be produced. Ponds, shown here on the bottom left picture. That's actually a picture of the Aquaculture Research and Demonstration Facility here on the Delaware State University campus. And this technology has been around for thousands of years. It's quite a simple technology, but it's very effective. Cages and pens, top right picture. These are small cages growing tilapia in a river in Brazil. But actually, it's interesting that this was one of the early aquaculture technologies, really kind of afforded people an opportunity to grow fish and kind of control what they had. That idea of farming again. But now that this technology is really coming full circle, and a lot of the salmon is now being grown offshore in very large cages like this. So the technology, obviously the specifics of that technology have changed quite a bit, but the basic principle has really remained the same and is being quite useful in terms of producing large quantities of aquaculture products. Raceways here on the bottom right, these are concrete, which is fairly common for raceway construction. But these are typically applied in an area where you've got some elevation change, some free-flowing water, and you allow that water to kind of flow through these long concrete runways. And the idea there is that as that water flows through, it keeps the water quality sufficiently high for your fish to thrive, and you can produce large volumes of fish that way, really with very little input once the system is built. You have to feed your fish, but you don't really need to spend money to aerate the system and kind of some of the things that we would have to do in other technologies to keep the environment suitable for our fish. And the top here, again, another picture from the Delaware State University Aquaculture Research and Demonstration Facility. This is a recirculating system. This is quite a small recirculating system compared to commercial production. But the idea here is that we really control all aspects of the environment in that system. We can control temperature, we can control salinity, we can control lighting. So we really are able to take what would be a fish that wouldn't normally grow in an area and produce that fish in a given area. And so that technology allows us to do that. And this is a technology that's really becoming quite popular for a variety of reasons, including environmental containment. It's much easier to treat this. Obviously, if you're out in the water in a cage system or in a raceway system where you're out part of the environment, it's a little bit more difficult to manage the wastes coming out of that. But if we move that system indoors and we kind of control that and contain that, we've got a lot better control over what comes out of that facility and leaves that facility at the end of the day. So these are some common aquaculture species. Again, most are probably familiar, some may not be. And so I always kind of, there's things like, again, frogs, turtles, alligators, macrobrachium, which is a freshwater shrimp, or a prawn, some people call it. And then other things like aquatic plants and algae are all kind of under this aquaculture umbrella. And then, of course, there's lots of things like salmon, catfish, tilapia, and then clams and oysters that are things that we might expect. But so the aquaculture umbrella is quite varied. And one of the reasons that I enjoy this field so much is that we really get to work with a lot of different species. So it's very exciting all the time. So take a little bit of a snapshot closer to home and look at the Delaware aquaculture industry. In terms of finfish aquaculture, some of you may be familiar with Blairview Farm in Houston, Delaware. They were a closed tilapia recirculating system. They were producing large volumes of tilapia every year for live markets up and down the East Coast. And for a long time, they really were the only farm in that sector. So they were producing finfish in a closed recirculating system. We also have Delmarva Aquatics in Smyrna, Delaware, and that's an interesting business. They actually produce eggs and fry or small fish for other people to grow. And they kind of focus on striped bass and yellow perch and things like that. So they actually distribute those all around the world. So it's an interesting business and really kind of one of those things that you'd never know it was there unless somebody told you about it. And then there's lots of other things that kind of fall under this aquaculture umbrella that we do. Crab shedding, for example. Blue crabs are our biggest fishery in the state of Delaware. And so to get those soft shell crabs, oftentimes they're put into these holding systems where they're allowed to peel, and then they're harvested once they come out of that exterior shell for that soft shell market. There's a couple of people that are doing pond stocking. So if you have a recreational pond and you want to ensure that your fishing on the weekend is good, you may buy and stock fish into that pond. There's people that are doing eel capture and haul, where they're taking those eels, and Ed showed a picture of one of the eel pots, and people are taking those, actually trucking them out of state. There's a farm in Maine actually that will take those eels and they actually on-grow them to a commercially harvestable size before they're processed for consumption. And some are actually shipped all the way to Asia for the same reason. Then, of course, there's people that are doing live bait production. And then aquaponics is one of the new things in the state of Delaware. So that's where you're taking recirculating aquaculture, and you're also taking hydroponic vegetable production, and you're merging those technologies together so that the nutrients from your aquaculture system become the fertilizer for your plants. So example of this is 302 Aquaponics right here in Dover. If you want to take a check out their website, and they do tours as well. So it's a neat operation if you get a chance to visit. And then the last thing is Shellfish Aquaculture. And this is where, a lot of my time, a lot of Ed's time has been in the last couple of years. There's a lot going on in this sector in the state of Delaware, which makes it very exciting. I think currently we have about 10 to 12 growers who are producing oysters. And so, so it's a really exciting area, an exciting time to be involved in the aquaculture industry, to really see this local production really coming online and being marketed up and down the state. And there's a few producers that are actually working now on finding markets outside of Delaware for that Delaware oyster. So again, we kind of come back to this question of where do fish really come from? And as we mentioned, it is there's seafood is a broad topic. It covers aquaculture, it covers fisheries. And there's a lot of nuance in there. And at the end of the day, I think the real take home, hopefully, is that, we're all working towards the same end goal of providing a sustainable and healthy protein source for folks to eat. How we get there may be different. The techniques that we use, the species that we use may be different, and the scale of production may be different. But at the end of the day, we're really all working to provide seafood locally and really around the world, which is kind of the exciting part of this field. So it's something that is international, but we're really all working together to produce seafood. This is always an interesting slide, and I think I'm just about done, so I'll run through this pretty quickly. Just kind of shows some of the growth of aquaculture and the little gray bars at the top versus capture fisheries on the bottom. And I put this up to highlight the fact that, capture fisheries, particularly in the United States, are exceptionally well managed, but there really isn't a lot more fish protein that we can harvest sustainably without depleting the fisheries that we have. And so, there's a lot of speculation that the only way that we're going to be able to continue to meet the demand for seafood products is through increased aquaculture production. And we're seeing that, as you can see here. I'm going to skip through some of this because I think it's a little redundant. So the future of fish, what does this look like? The take home here is as as human population increases, we really do need to be better and more aware with where our fish products are coming from so that we can ensure that everybody has enough fish to eat. And it's not just fish, but again, it's really just about protein production. So the estimate currently is that by about 2030, 62% of all of our fish products will be coming from aquaculture operations. And I think we're probably on track to meet or possibly even exceed that. And with that, kind of take any questions. I'll leave our contact information up here for a few minutes as we kind of transition into the panel discussion. Chris, if that's okay, that way people can write that down if they want to contact us afterwards. That'll be fine.
Yes, definitely. Thanks, Dennis. So if you have one-on-one questions that you want to ask of Dennis or Ed, just go ahead and send them an email, or you can do it through the chat here on Zoom. If you have questions for either of them at this point that you want to make public and share with everyone, we can do those questions. I have a list of my own questions to get things started, get things warmed up a little bit. So if you have any questions, go ahead and put those in the chat, or raise your hand and we can get those answered. So my first question for both of you, and unfortunately, Greg Caston from ProFish had some technical difficulties. He was not able to join us, which is a shame because I think he had some really interesting perspective to add. But so we'll run forward with Ed and Dennis for now. Can you guys tell us a little bit about what your jobs are and how they fit within the idea of a food system, or in this case, a seafood food system?
So thanks, Chris. We are extension specialists, right? And so much like terrestrial-based extension, we are trying to engage both members of the public, commercial industries that are associated with fisheries and aquaculture to essentially help communicate sustainable and scientifically accurate information. One of the pieces that Dennis and I are largely involved with is shellfish mariculture here in the state of Delaware. And so we regularly communicate with shellfish farmers, potential shellfish farmers. At this point, Dennis and I now have a pretty good handle on the industry, and I've kind of watched people come in who didn't have commercial production and are now producing oysters. And so that's kind of an exciting point in history. And so we're trying to do anything we can to help facilitate their economic growth because of the associated environmental, ecological, and economic benefits of shellfish oyster aquaculture. And so that's just some of the stuff that we do in terms of an extension umbrella. And then on top of that, we do applied research and some teaching of college classes to help communicate those things. And then Dennis, I'll kick it over to you if I didn't hit any tenets you'd like to talk about.
No, I think that covers it really well, Ed. Thank you. I mean, I guess that the way that I kind of describe what extension is for people that are not necessarily familiar with the cooperative extension system or Sea Grant is that, I kind of liken us to paid consultants. We do a lot of technical advising. We can help with things like that. We can help with, whether that's actual production, how do they grow things better? How do they fish things more efficiently? We can help with the business side of things. Not personally, I usually refer them to somebody that has more of a business background, but really we're a technical resource for people. And again, whether that is the producers themselves, people that are asking questions like, say, state legislators, for example, that need to know about this or need information so they can kind of craft regulations that make sense. We kind of address those questions.
Great, thank you. So you both are in Delaware. You provided a lot of perspective from Delaware. Is it possible for either of you to chime in on the fisheries and aquaculture status in Maryland, since we do have some Maryland folks joining us, and this project is a collaboration between University of Delaware and University of Maryland?
Absolutely. I can kind of take a stab at that initially. And I would say that the situation is similar but different. And by that, I mean, there really is not a giant, there's a much larger aquaculture industry in the state of Maryland, but it's not necessarily significantly more diverse. There's some great researchers, some great extension people, and lots of shellfish aquaculture. And that they've got a little bit more of a history in terms of how they've been doing shellfish aquaculture, and the mechanisms are slightly different in terms of how things are regulated and kind of the approach that Maryland is taking to shellfish aquaculture. But I think in some respects, it's a similar enough situation where some of the other forms of aquaculture that I mentioned, they tend to be expensive. They tend to not necessarily be as tried and true in this region. Recirculating aquaculture, as an example, tends to be expensive startup wise. So there's not a lot of those operations. There are some. And so I would say there are differences between the two industries, but they're really not that significant, I guess, is my take home. Other than, as I said, Maryland has been doing shellfish aquaculture longer, so they're a little bit more further advanced than the industry in Delaware. But for the most part, they're fairly similar.
So we have a question from Jerry. What are the environmental implications of aquaculture?
Sure, no, and that's a fair question. And I think it's one that aquaculture gets beat up over quite a bit oftentimes, and not necessarily without merit to some extent. So this is definitely one of those conversations that I try to approach with some nuance. clearly the aquaculture industry has done some bad things in the past. And there's, and the industry, as the science has changed, as the technology has changed, those things have improved in some respects, and I think one of the mentions was, mangrove destruction. That's something that the industry did back in the, late 80s, early 90s, because they didn't know any better. And now the industry has realized that those areas really are not productive, and they don't support aquaculture to the extent that it's, economically, doesn't make sense. So we've moved away from those areas, and that's where some of the technologies like recirculating systems, offshore production alternatives are coming in, where people are trying to be more aware of that. And there's a lot of efforts to mitigate that through feed selections and other things as well. So clearly there is a history of, we've done some bad things as an industry, but we're trying to kind of move forward in a better way.
Great. Ed, anything you want to add to that?
No, that's pretty good in terms of,
Okay.
like the net pen type of consideration. Yeah.
Sure. So I have another question. COVID obviously had some pretty big implications for our food system here on the Delmarva Peninsula. Can you comment sort of what COVID has done to the seafood industry, whether that's fisheries or aquaculture?
You want me to go first?
Yeah, let me take that up.
Yeah, so that's a good question, Chris. COVID was like the universal interrupter for all things, and fisheries and seafood production were not free of that impact. In fact, many of our commercial fisheries are relative scale, but they have direct markets to New York. Most of our Atlantic striped bass was sold either to Maryland or New York-based markets for restaurants. In fact, that's where a lot of the higher value product went, with things like Atlantic striped bass. And unfortunately, compliments of COVID and restaurant shutdowns, that supply kind of evaporated relatively quickly, almost overnight. Similarly, our marine aquaculture folks, the folks that were growing oysters, and so we didn't talk about essentially when those folks, we only became up and running selling oysters in 2018. Most of our folks that were selling oysters or farming oysters were looking to 2019/2020 to be like their big opener season. And so when COVID hit them, many of them had to call an audible and essentially diversify, mostly to direct sales. And so what we saw was, one of the things that Dennis and Chris and I did was participate in helping construct a framework to kind of connect consumers to proprietors, so that we could make those types of arrangements without, essentially contaminating ourselves with bias. All we did was provide web links and web forums and share that information so that customers could go find locally sourced seafood, kind of similar to the farm to table movement, very much akin to that level of effort, but trying to help them. And what we saw is that some of our shellfish farmers, because they were so new, were fairly adaptable. We saw pretty high level of success with some really novel ideas. One of them was selling at a meat market. So he put in a freezer there and was selling oysters through a business partnership. One of them took over a bunch, essentially a circuit of what are those things called, farmers markets. So again, something that's fairly common to a terrestrial, land-based agricultural extension idea, but to a seafood processor, probably not the first idea. And we found that we were fairly successful. In fact, many of the commercial industries were very thankful about our early integration and attempt to kind of work with them to kind of help expose what they were doing and help direct sales.
So I'll just add that I think Ed covered the specifics really well. I think, nationally, and it's interesting to kind of think about consumption patterns with seafood. Seafood is not largely, but it's oftentimes consumed at a restaurant. And so with COVID shutting down restaurants, a lot of the standard markets for seafood were closed immediately. So as Ed mentioned, our producers were small, nimble. They were able to very quickly pivot and did quite well. But that was not the case nationally necessarily. A lot of, the aquaculture industry has suffered quite a bit. The couple of folks over at Virginia Tech have done a couple of great surveys looking at, the impact of COVID on the aquaculture industry. And some of those numbers are quite staggering, just lots and lots of loss. And then through some lobbying efforts through groups like the East Coast Shellfish Growers Association and the National Aquaculture Association, they were able to get some aid money kind of funneled to aquaculture producers to kind of supplement that income to kind of help them through the pandemic. So some really trying times for the industries overall.
Definitely. Thank you. So switching gears just a little bit, Maria asked a good question about changes in air temperature and water temperature. Are you seeing, have we seen, will we see implications for fisheries and aquaculture due to a changing climate?
Ed, do you want to take this one or do you want me to?
No, I'll jump in. So yes, it's a good question, and absolutely. We are witnessing changes in real time. Many fisheries and aquaculture scientists are some of the first to kind of point at climate change and say we have an issue. With fisheries, it's pretty easy. We've seen contractions in range. When you think about something that was harvested 20 years ago, say winter flounder, it's now gone, right? You can't go catch that in Indian River Inlet anymore. And so I can point to an example, and many people have this history, this knowledge, 20, 30-year knowledge of an animal that's no longer there because essentially we were on the fringes of its temperature threshold. And so it's been a contraction of its overall home range. And because we were on the fringe, we can witness that. And we can point to animals within our lifetime and kind of see that. We've published a number of research papers that have made connections. All four of the drum species that we interact with, black drum, weakfish, Atlantic croaker, I think we had 12 indices of abundance generated from Delaware-based data that were linked to water temperature or an atmospheric index that essentially is a predictor of water temperature. So we're very much experiencing those things in real time. When you look at some of our aquaculture industries, we're perhaps better buffered, right? The range for the eastern oyster, the most lucrative organism that we culture, extends from Maine to Florida theoretically, or into the Gulf of Mexico. So I think we're a little bit better off. There's going to be some details there that we'll have to deal with. One of them being ocean acidification. When you look at ocean acidification out on the West Coast, it's very much a big deal. I have ocean acidification monitoring programs that we do not have in the Mid-Atlantic region. We look at things like outbursts of harmful algal blooms that we suspect may increase because of temperature, relatively short changes in temperature that'll ultimately affect seafood consumption and seafood harvest, right? You can't go harvest bivalve shellfish if they're loaded with harmful algal bacteria or harmful algae rather. And so we very much are realizing this and witnessing it in real time on the scientific end. And it's something that essentially production pathway is going to have to attempt to deal with.
And just kind of add on to that a little bit, one of those adaptations that we're seeing, salmon is kind of an interesting example. For the last 2 to 3 decades, salmon really has been grown in nearshore or, not quite offshore, but nearshore cage kind of situations where those animals are out in that environment. But for a variety of the reasons that Ed mentioned, including temperature change, harmful algal species and things like that, there's more of an increase in desire to bring those systems on land into a recirculating system so we can control that production. And so there's, again, lots of interesting kind of conversation around that, including, you bring your product closer to market to minimize that shipping cost and things like that. So there are a lot of adaptations being made in the technologies that are being employed. And then, of course, on the biology side of that, there are species or there are groups like Rutgers, for example, that have active oyster breeding programs where they're trying to select animals that are more tolerant of different conditions. So there's a lot kind of going on behind the scenes as well.
Thank you. So we're nearing the end of our hour, but I want to take one more question from Rick in the chat there. Hey, Rick, good to hear from you. Are there fishery management issues to be dealt with offshore wind, essentially? So we're hearing a lot about it here in Delaware, certainly in Maryland as well. Ed, can you speak just sort of briefly? I know it's a delicate and in-depth issue, but if you could just give sort of your 2 cents from where you stand, that'd be great.
Yeah, the short answer is absolutely. The offshore wind farming has a great potential to provide passively sourced energy. But in laying some of those ground cables, we are seeing conflict with potential bottom gear, right? Things like dredges that want to drag on the bottom. And it's not necessarily just within wind farm lease areas, but also within areas in which cables go from leased farm areas into landing sites for energy distribution. And so we are just now kind of looking at some of the implications associated with that, right? Like you drop an electrified cable down there and they're supposedly buried in the sediment. But there is going to be some level of impact. And so we definitely see that on the forefront.
Great, thank you. So Maria, I think that marks sort of the end of our segment. I'll thank you, Ed and Dennis, very much for your input and your information. And again, if you guys want to put your emails in the chat box, maybe that'll help
Thank
folks
you.
if they want to email you later. But Maria, thank you for the opportunity to talk with everyone today, and I'll pitch it back to you.
Thank you all so very, very much. That was so fascinating. I learned so much, and I'm sure we all did. So in the chat, I put our the little survey tool, if you wouldn't mind taking just a couple of minutes and filling that out. I want to remind you that we're skipping next week because it's Memorial Day, but the week after we will be very glad to have Nate Bruce, who is our new cooperative extension farm business management educator, and he's going to be talking a little bit about that interplay, that interconnectedness between agricultural production and consumer markets. And so please join us on June the 6th from noon to 1. And as I said, please fill out our survey tool, and we will provide that feedback back to our wonderful presenters from today. And thank you again, gentlemen, for sharing your expertise and knowledge. So fascinating. You really helped us see how fisheries and aquaculture and the whole water-based world that we live so close to is interconnected with our food system. So thank you very much.